Hello student, and welcome back to your favorite technical channel AVM Tech Android. So today we are again available here with the fourth lecture of chapter 2 Basic Mechanical Engineering. Chapter name is Property of Gases. So at present in the chapter number 2 we have to discuss topic number 4, that is constant temperature process, which is widely known as isothermal process. So how we are defining constant temperature process or isothermal process? So constant temperature process or an isothermal process is a thermodynamic process that occurs at constant temperature. So during this process, temperature of the working substance remains constant while the pressure and volume changes. So temperature is constant in this process. This is a PV diagram for this process, and we know that as per Boyle's law, when temperature is constant, you can say P is inversely proportional to volume. This is a rectangular hyperbola which is known to us. So if we talk about the basic relation, as per the ideal gas law PV equals to MRT, what we'll see is temperature is constant in our case, MR is also constant, so this term MRT is constant, so we can say that PV equals to constant, or we can say that P1V1 equals to P2V2. And as we know, this is a Boyle's law, that is at constant temperature pressure of gas is inversely proportional to the volume, that we learned already in the previous lectures. So now we have to find out what is the work done, what is the heat supplied or heat rejected, and what is the change in internal energy. So first thing which we have to find out is the work done in this process. So as we know that W, that is integration between initial state V1 to final state V2 into PdV. But we know that PV is equals to constant. So P is equals to C upon V. So instead of this P, we have to put C by V, and we have to go for integration. You learn integration in your school days. So when we'll go for integration of 1 upon VdV, we'll get W, that is equals to C ln V2 by V1. So this ln is log base E. And also we know that this C, that is equals to P1V1, that is equals to P2V2, that is equals to MRT. So instead of the C which is available in this equation, we can write C, that is equals to MRT into ln V2 by V1, or we can write MRT, that is replaced by P1V1, or that is replaced by P2V2. So I can write W, that is equals to P1V1 ln V2 by V1, or it is MRT ln V2 by V1. Now whenever the expansion process is going on, or particularly in IC engine, you can say it is a expansion stroke or a power stroke, where volume V2 is more than V1, so work is greater than 0, and that is work done by the gas, and that is a positive. When the compression stroke is going on, or when the compression is there, V2 is less than V1, work is less than 0, it is negative, and work is done on the gas. So this is a negative and this is a positive one. So now work done formula is available with us. Now we have to find out what is the delta U value, that is change in internal energy. We learned that internal energy is a function of temperature. So change in internal energy is again a function of change in the temperature. When the temperature is constant, this delta T is 0, so delta U is 0. So here there is no change in internal energy. There is no change in internal energy during the isothermal process. So as per the first law of thermodynamics, Q equals to delta U plus W, and this delta U is 0. So what we can see is this Q equals to W. So this Q equals to again MRT ln V2 by V1, or you can say MRT is replaced by P1 V1, or you can say MRT is replaced by P2 V2, and therefore we can say that the heat supplied is converted into work during expansion, and that is 100% possible when we'll talk about isothermal process. This is a very important thing. So now we have to talk about the summary for the different relations. Here you can see different quantities, here expressions, and in the last column we will observe remark. So for the isothermal process, temperature remains constant. Basic law, that is PV equals to MRT, that is PV is equals to constant, that is Boyle's law. Work done, that is equals to W, that is equals to MRT ln V2 by V1, that is positive for the expansion. Change in internal energy, that is 0. Heat supplied Q, that is equals to W, and that is equals to MRT ln V2 by V1. And as per the first law, Q equals to delta U plus W, where delta U is 0, so Q is equals to W. So this is about all the formulas, how they are derived. You have to remember either these formulas, or it is better option that you must derive from the basic, so there is no need to remember anything. In the rare case, the question is there in the exam to derive the formula for W, for delta U, as well as for Q. Otherwise, numerical will be asked. So now we have to solve one sample numerical related to isothermal process. The data is given here, that is 1 kg of air that expand isothermally, at 300 Kelvin from 0.05 meter cube to 1 meter cube. We have to find out what is the work done and heat supplied. R value is 0.287 kilojoule per kilogram Kelvin. So here mass is given, initial temperature is given, initial and final volumes are available. It is clearly mentioned the process is isothermal process. We have to find out W and we have to find out Q. So we can find first part, that is a work done. So work done for isothermal process, that is MRT ln V2 by V1. M value is 1, that is given in the data. R is 0.287. If this value is not given for air, you have to remember and you have to write by your own. T, that is 300 Kelvin, ln, that is log base E, 0.1 divided by 0.05. Now here to find out the value of this ln 0.1 divided by 0.05, you have to use the calculator in which ln is there, that is log base E. So some practice is needed in this case. So it is advisable for all the student कि भाई आप कैलकुलेटर का ठीक से यूज़ करना, वरना एग्ज़ाम में ये सॉल्व ही नहीं होगा. हाउ टू फाइंड आउट ln ऑफ 0.1 डिवाइड बाय 0.05, ये आंसर ही नहीं मिलेगा, तो अल्टीमेटली आपका पूरा न्यूमेरिकल रॉन्ग हो जाएगा. सो इट इज़ एडवाइजेबल कि आप कैलकुलेटर का ठीक से प्रैक्टिस कर लो. नाउ व्हाट यू विल ऑब्जर्व हियर इज W, that is equals to 0.86.1 ln of 2. So ln of 2, that is 0.693, and your answer is 59.6 kilojoule. Now for the isothermal process, as we know, Q equals to W. So the answer that is 59.6, that is same answer for the supplied heat. So W and Q answers are same, and this is the method how you have to solve the numerical. I hope it is very much clear to you. So this is end of this lecture. Now do not forget to subscribe this channel, like this video and share this video as well as this channel to your friends which are in your institute or which are in the other institute. Thank you.